why is this information-centric view better? What is it that Proteus can do that we can't do with C++, say, or even like normal AI? Why would we use Proteus? But to answer that, we really need to know a little bit more about Proteus, how it works. So I'm going to go into that. So what I want to do is just give an overview of how Proteus works and how you would program in it, at least an intro. Mm-hmm. And if you want more details, you can ask, but I'll give an intro. So humor me on the theory part here. In Proteus, there's one underlying thing called an infon. Infon just means piece of information, but I got tired of saying that, and Keith Devlin coined the term infon to mean piece of information. So it doesn't mean like proton, infon, it's just piece of information. So in Proteus there's an infon. Infons have states, and we represent them. Let's say we have. I'm gonna write something that's kind of standard. Let's say that's 32 bits of memory, 30 bits of information, 32 bits of state, so about 4 billion states. And we can add more, and we add more, and we can just keep going, right? So this is one way of representing how much states we have. This kind of diagram that you would probably see in a computer book telling you how things are stored in memory. So I'm going to use it. So let's say we have 32 bits and 32, and it goes on. So in Proteus, there are 3 different ways of dividing up an infon like this. And the units are states, bytes, and then arbitrarily sized things, so a list. So if we divide it by states, I can say I have a 10-state system and a 3-state system and a 17-state system, and I can stick them together like that. So you don't see what it's doing is it's really just sticking them together. So you could say this whole thing is a 30-state system, or you could say it's let's say 19. We could say 32. Just to get our math right here. So it's a 32-state system. So I could also divide that up into bytes. I could divide it into 4 bytes of 8 bits each. So we can divide it into states, we can divide it into bytes, and that's a string, or we can divide it into into a list, which is arbitrarily sized items. So here's the syntax for that. If we're doing it in states, we just use like normal number syntax. So, but we do it like this. So let's say we want to represent a 16-state system that's currently in state 7. I'll show you how to do that, and then I'll talk about it. You say times 16 plus 7. So multiplication is kind of like moving a cursor in a way, right? Because if you're measuring in bits, and you say times 2, it's like shifting the whole thing by 1 bit. Or if we're using, let's say it's decimal numbers, and we multiply times 10. It shifts the decimal point, or it shifts the whole number left, or if we divide right the other direction. So that's what we're kind of doing here. We're saying move the cursor over 16 states, and then it's in state 7. So this is a 16-state system, and it's in state 7. And if you kind of think of there being a 1 here, the multiplication on this actually works out the way you would expect it to. But the thing to understand is that we're talking about states. So this is, the units for this are in states. But we can use other units, so let's use bytes. Here's how we would do that. times 5 plus HELLO. So that is a system with 5 bytes, and here they are. Here's the value it is. Now, typically, you don't have to do this. You can just say plus 7, or just 7, and it's going to say, well, I don't know how many states there are. Maybe it doesn't matter, unless you need to tell me. I'm going to assume it doesn't matter. And likewise, you can leave the size off here if you want to, and it'll just figure it out for you that it's 5. You can put a plus here if you wanted, plus it actually will work. But just syntactically, you can leave it off. Now, a list is the same thing. Let's say that we have a list of, lists can be a list of numbers, list of strings, or a list of lists. So let's look at an example. Use curly braces. 5, I, 1, 2, 3. So here we have a list of a number, a string, and another list. Now, if you think about this logically, it's stringing it up like this. So when you put these boundaries on, like how many states is this? How many bytes is this? How much room is this taking up? It's thinking of it as just being one big long piece of information. So you could actually reinterpret this as a big number, or as a string of bytes. And that's important to understand, that it's looking at this as one big long piece of information right here. So in a way, we're getting the low-level details that you would get from C, because we can actually talk about memory here on a pretty low level. So so it has that property of being able to work on a very low level with computer hardware, which is kind of cool. So these are the 3 things. We have infons measured in states, infons measured in characters or bytes, and infons measured in items. So if we want to add the size to this, there's 3 items, so we'd say times 3 plus that. And because it's a list, it knows that this 3 is measured in items. Now, the arithmetic actually works. And that's kind of one of the things that took me a long time to figure out how to do, is to make the arithmetic work right. So, like in the implementation right now, there actually is a separate section of code to do the numbers, but there wouldn't have to be. I just want to take advantage of the fact that computers can very rapidly do arithmetic. But I could easily rewrite it so that there was just one algorithm that processed all 3 of these different styles or different ways of dividing it, and it would work correctly. In fact, I'll probably do that soon, just because it's a good idea. And then it can later on figure out how to optimize it. So those are our components. Now, those are our components for making a model. Model is an infon, or a description is an infon. Those are words that I use interchangeably. Infon, model, description, depending on how I'm using it, who I'm talking to. So you can think of this. One way to think of this is a list, obviously, or an array, or a piece of memory, a structure. But you can also think of it as that's all I get for staying awake till like my brain is. What was I going to say? I don't know where I was going with that.
Sorry, it must not be important right now.
Okay.
So let me ask you a question then.
Okay.
Would this be a good place to maybe use like a different colored marker while it's still up there and
Sure.
describe how like another programming language works, something that people are familiar with? Because it seems like the base...
Oh, that's what I was going to go on.
Oh, perfect. Okay. Nice.
Okay, so so another way to look at this is like a struct in C. So this would be, so in C we might have struct, whatever, record. And then we have an integer, so let's say int. We have to give it a name, and a string. Let's be char star. S, and then an array, let's say, of integers. So this isn't a perfect match because this is very untyped right now. But the idea is that this is what you would use if in C you were going to use a structure. You could use a list like this, and I'll show you that you can make these very highly structured if you want to, with types and all that. But that's the first conversion. Is that yes, this can be a list of things. It can be an array, but it can also act like a struct, a C struct.
And a C struct is just a fundamental way of storing information in C.
Yeah, it's C, and all languages except for maybe very old ones have a way of combining data elements into a single variable. So you can say person record, and it would have their name, their address, their age, their salary or whatever, all in one variable. And you can say current employee equals this, and it will copy all of that. So it's like using all of these datas, consolidating all these data elements into a single variable. Okay. And that would be common knowledge. So if you're writing a technical article, you would explain what a struct is.
That's good. I think to be able to get both sides in the video, then I can put stuff in for certain audiences. Right. So is this like a good? Maybe you already covered this, but it's technically over my head. Is this going to be obvious to folks? Technically, and then we could revisit from another perspective, but why Proteus is better? Does this get into like why?
Not yet. Okay. There's a lot of information.
Okay. So. No, that's all right. It's good for me to know so I can kind of track and take notes of like the process. So
right.
So right
now I'm kind of making a conversion. This is how if you were a C programmer, you can think of Proteus.
Okay.
So we've kind of talked about arrays, lists, strings, numbers, and structs. So those are all like C, Java, C++ concepts from kind of normal imperative programming.